Alright guys, Tuesday already. Today we're going to talk about stem and leaf plots. So I want you to just know that stem and leaf plot, we'll say a stem and leaf plot, is a way of organizing. We've looked at lots of ways of organizing, right? And displaying data using the digits of the data values and seeing how values are distributed. So, things we need to remember. The last digit of a data value is the leaf. So when you think about a tree, that's kind of hanging from the leaf, right? The tree is not hanging from the leaf. The leaf is hanging from the stem. The remaining digit, or digits, are the stem. So that's why we have a stem and leaf. So the key, remember, we need a key just like we do on a map. The key explains what each represents. So if we had a stem, so this maybe was for call times, and we have a leaf. If our stem here is 0, 1, 2, 3, 4, and 5, and our leaves were multiple things. We have a 9 here, a 0, a 3, a 6, and an 8. Now we don't use commas on our stem and leaf plot, but we do leave space between them, although our leaves would only be a single digit. So you should know that even if there is no space between them, they're individual call times, individual data values. Each one of these leaves are 1 and 4, 2, 1, 7, and 3. So our key might say that 2, and that's that line in between, 1 equals 21 minutes. So this would be 9 minutes, 10 minutes, 13 minutes, 16, 18, 21, 24, 32, 41, 47, 53. Do you see how that works? So each individual number on the right under the leaf are individual data values. So this stem and leaf plot shows the length of a set of customer service calls. If we asked you what the mean call time was, you would add up all of these call times. So 9 plus 10 plus 13 plus 16 plus 16 plus 8, and so on and so forth to find the mean. To find the median, you would see how many call times there were total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's an even number. So between the 6th from the bottom and 6 from the top, you would have to find the average. So 1, 2, 3, 4, 5, 6. So between 18 and 21, right? 1, 2, 3, 4, 5, 6. So between 18 and 21, you would find it to find the median. What is between 18 and 21? 18 plus 21 would be 39. divided by 2. What do you think, guys? 19 and a half. How many calls were more than 10 minutes? So everything more than 10 minutes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 calls were more than 10 minutes. How many calls were at most 30 minutes? So up to 30 minutes. 1, 2, 3, 4, 5, 6, 7, 8. 8 calls were up to 30 minutes. Gosh, I do not like that at most. That throws my head off. Does that bother you guys? All right, if I gave you another stem and leaf plot, I want you to try and decide for yourself. So this stem and leaf plot represents the age of hockey players. I had a cousin who played hockey. He played for the Spartans, and then he played in Italy, and then he played for the Detroit Metro City Mechanics when they had a UHL team. Stem, leaf. All right, so the stem is 1, 2, and 3. There's a 9 next to the 1, a 1, 2, 3, 3, 5, and 7 next to the 2, a 0, 1, 2, 4, and 6 next to the 3, and our key is that 3, 0 equals 30 years. Okay, so if we want to find the median age, we're seeing how many total are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ugh, another even. So 12. So we want 6 less and 6 more. So we're finding in between. So 1, 2, 3, 4, 5, 6. This is 6 less and 1, 2, 3, 4, 5, 6. So between 25 and 27 would be our median age. So there is one number to find the average. Would be 26, right? The mode age, what occurs the most? What age is most prevalent here? Well, I only see one number happening more than once, and that's right here, this 3, which really represents 23, right? The range of ages, you would take the highest age, right? 36, minus the lowest age, which was 19. So the range would be 17 years between the oldest and youngest player. How many players are at least 25 years old? So at least 25 would account the 25. So we'd have 1, 2, 3, 4, 5, 6, 7. All right, do you guys see how we can use stem and leaf plots to read and organize our data values? Hopefully that helps a lot. Now sometimes our stem and leaf plots will show multiple digits in the stem. So if I have 9, 10, 11, 12, 13, and 14 in my stem, and my leaf side was 4, 4, 1, 5, 9, 4, 6, 8, 7, 0, 6, 2, 8. So remember, my key might be 14, 2 equals 142 minutes. So again, each number on the leaf side is still only representing one data point. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. So that will help you find the median, right? The 7th one should be our median because we should have 6 on each side and 1 in the middle. That would be 13 data points. So we could count 1, 2, 3, 4, 5, 6, 7, and we would have 116, so 116 minutes would be our median. Our mode would be anything that occurs most, and I see 294s. Nothing else has 2 or more than 2. And then our mean, remember, we would add these up. 94 plus 94 plus 101 plus 105 plus 109 plus 114 plus 116 plus 118 plus 127 plus 130 plus 136 plus 142 plus 148, all divided by, we said there were 13, and that would give us our mean. All right, guys? Let me know if you have any questions. Hopefully that helps, though, seeing how we use stem and leaf plots.